In this video, you will learn how to find the lengths of segments in circles. So we have segments of chords, secants and tangents. So let's discuss segments of chords first. All right, from the segments of chords theorem, if two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So we have two chords here, AD, AB, and CD. So that means for chord AB, the length of AE times the length of BE is just equal to chord CD, which is equivalent to the length of the product of the length of CE and DE. Now let's take a look at this sample problem here. All right, given this problem here, we need to find the length of chord AB and CD. So we're given here the segments, the length of the segments of each chord. So AE is equal to x plus 2. Then BE is equal to x plus 1. CE is equal to x plus 4. And then DE is equal to x. So how are we going to find the length of chords AB and CD? So we use the theorem, this one. All right. And then we solve for the value of x first before we can solve for the length of chords AB and CD. So that would be AE times BE equals CE times DE. So our AE is x plus 2 times BE, which is x plus 1, equals CE, which is x plus 4, times DE, which is x. Right, we multiply and then we simplify. So in this case, we use the FOIL method, and then in this case, we use distribution. Right. So x plus 2 times x plus 1 is just equal to x squared plus 3x plus 2. You just have to multiply x times x plus 2 times x, x plus x times 1, and then plus 2 times 1. And that would give us x squared plus 3x plus 2. And then x plus 4 times x, we distribute x to x plus 4. So this is x squared plus 4x. Then we group like terms. We simplify this. We can write everything to the right or left. Okay, so let's put all of the terms to the right or the left. So that would be x squared plus 3x plus 2 minus x squared minus 4x equals 0. X squared cancel out here. 3x minus 4x is just negative x, and then we have plus 2 equals 0. Then we transpose 2 to the right, that would become negative 2. Negative x is equal to negative 2. We divide both sides by negative 1. Therefore, the value of x here is equal to 2. Now that we have the value of 2, so we can now solve for the lengths of AB and CD. Right. Okay, now let's solve for the length of AB, segment AB, or chord AB. So chord AB is just equal to segment AE plus segment BE. So that is x plus 2 plus x plus 1. But we already have the value for x, which is 2. So we just substitute the value here of x2 plus 2 plus 2 plus 1. So this is 4 plus 3 equals 7. So that is the length of chord AB. And now for chord CD, okay, chord CD or segment CD. Let me delete this. Right, chord CD is just equal to CE plus DE. So that would be x plus 4 plus x. And we know the value of x, which is 2, so we just substitute here 2 plus 4 plus 2. So this would give us 6 plus 2. Therefore, chord CD is equivalent to 8. So that's how to solve for the lengths of the segments of chords. Now let's discuss segments of seconds. All right, from the segments of seconds theorem, if two second segments share the same endpoint, endpoint here is E, outside a circle, then the product of the lengths of 1 second segment and its external segment equals the product of the lengths of the other second segment and its external segment. So this would be EA times EB is equal to EC, this one, times ED. So that is the length of 1 second segment, which is EB, and then its external segment equals the product of the lengths of the other second segment, which is ED, and its external segment EC. Now let's solve a sample problem here. All right, let's solve this problem here. So we're given here a circle with segments of seconds. So that would be the length of the external segment times the length of the second. The length of the second. And then equals the length of the other second and its external segment. So that would be Z times Z plus 12 equals 4 times 4 plus 8. Now we distribute Z here. So this is just Z squared plus 2Z equals 4 times 12. So this is Z squared plus 2Z equals 48. All right, so we have a quadratic equation here. We can move or transpose 48 to the left. Okay. Then our equation would be z squared plus 2z minus 48 equals 0. So let's check if we can factor this one. If 48 is factorable. So what are the factors of 48? That when you multiply them, it would equal to negative 48. And when you add them, it would equal to positive 12. Oh, this is 12. This should be 12. Sorry. Okay. Should be 12. All right. So our equation is z squared plus 12z minus 48 equals 0. That is not factorable, so we use the quadratic formula. Okay. You still remember the quadratic formula? X, or in this case, we have z. So this would be z equals negative b plus minus square root of b squared minus 4ac over 2a. Right. In this case, the values of a, b, c are equal to 1, 12, and negative 48. And then we plug into our quadratic formula. So this would be negative 12 plus minus square root of 12 squared minus 4 times 1 times negative 48 over 2 times 1. So this is just equal to negative 12 plus minus square root of 36 over 336 over 2. And then we can write 336 as the square root of 16 times 21 over 2. And 16 is a perfect square. Let me delete this. Right, so z is just equal to negative 12 plus minus square root of 16 times 21 over 2. And then 16 is a perfect square, so we can get the square root of 16, which is 4. So that is 4 square root of 21 over 2. And then we can reduce 12, 4, and 2 by dividing them by 2. So that is 12 divided by 2, 4 divided by 2. So this would give us a value for z. So z is just equal to negative 6 plus minus 2 square root of 21. So that is basically negative 6 plus 2 square root of 21 and negative 6 minus 2 square root of 21. So z1, z sub 2. All right. All right. How about segments of secants and tangents? All right. How about if we have a secant and a tangent on a circle? So if a secant segment and a tangent segment share an endpoint outside the circle, this point E here, then the product of the lengths of the secant segment and its external segment equals the square of the length of the tangent segment. So the tangent segment here is EA. So the square of that is just equal to the product of the external segment EC of the second segment and ED, which is the second segment. EC is the external segment and ED is the second. All right, let's solve some sample problem here. All right, we're given this problem here and we just need to solve for the value of y. So this is 9. Okay. Okay, we have tangent y, and then our secant. We just have to, okay, that would be the square of y equals 2 times 2 plus 9. So that is the external segment, which is 2, and the secant, or the length of the secant, which is 2 plus 9. So this is y squared equals 2 times 11. So this is just 22. Get the square root of it. So y is equal to square root of 22, or plus minus square root of 22.